Good day everyone and welcome again to another science video lesson, and in this video lesson we will going to talk about the essentials of module number 1, and that is all about the lithosphere. Alright, so in this particular module, we will talk about more about earth science, and the first topic that we have right here is the lithosphere. Alright, so in this lesson, we will try to discover what are the things that we can find on the earth's lithosphere and its significance, all right? Its significance to the next lesson that we will have in the future. All right, so without further ado, we will start now our video lesson. All right, so our topic today is about the lithosphere, and as we all know, lithosphere is a part of the earth. All right, so in this topic that we will have, we will discover what are the layers of the earth that makes up your lithosphere respectively, and what is the significance, okay, of this layer, all right, of this special layer to the next lesson that we will have about plate tectonics. All right. So now, have you ever wondered, before we start, have you ever wondered if humanity's goal, all right, if you will change the humanity's goal is to dig down deep inside the earth. So what do you think? All right, what do you think is the what do you think is the longest or the deepest, all right, the deepest tunnel that is dug by humans, or tunnel or a hole that is dug by human in through the earth? All right, so what do you think? Okay, so let me show you some pictures about the attempts. All right, these are the attempts or some digging process done by humans, all right, whether it is on mining or just for scientific purposes. These are some achievements done by humans in terms of digging. All right, so we have it right here. All right, so we have the Kola super deep borehole. This is on okay, this is on Russia, and the Russians dug a hole that is around 12,200 meters, all right, of hole, and the hole is 23 centimeters wide. Right, so the hole is right here, and if you put a coin down that hole, it will take up 50 seconds, all right, just to reach the bottom. All right, but don't worry, you will not be able to fall inside this hole because the width of this hole is not enough for you to fit in. All right, so what is the purpose of this one? Russians wants to dug up a hole, and during the Cold War, to prove to the world, probably that they can, all right, they have the power to drill down to the center of the earth or something like that. All right, but unfortunately, when they reach 12,000 meters, what happened is the drill that they are using started to melt because the temperature down there at 12,000 meters is starting to getting hotter. All right, the drill that they use melted and rendered useless. So as of now, as we speak, so this particular facility that is in the Kola region of the Russian territory. All right, so the Kola region, so it is now abandoned, and the hole that is left behind during the process is still there. All right, so let's take a look at the other achievement. So now, due to the ever increasing demand in oil, all right, so we have right here an oil well in Qatar, and they found this oil down underground or underwater at around 12,290 meters. All right, so okay, now at that depth, they be able to extract the oil. That is the Al Shaheen oil well in Qatar. All right, so this oil field that you have, this is not the only one, right? So there are a lot of this in that particular field in Qatar. All right, so it is used to extract oil. So in extracting oil, we need to drill down deeper to the crust. All right, to the Earth surface in order to extract this precious resource. All right. Next one, we have right here a not too deep, all right, a not too deep hole. But why is this amazing? Is because it continues to burn. All right, it continues to burn because it contains natural gas. All right, so it contains natural gas because of an accident during drilling process. This whole area collapsed and suddenly exploded, and as of now it's still burning. All right, so yeah, that is the door to hell in Turkmenistan. So we have here the Bingham Canyon mine in Utah. All right, so this is a one of a kind open pit mine, which is you can still see the sunlight. All right, so this is deep. Now, to give you a perspective of how deep it is, you can fit the Burj Khalifa from the bottom of this mine down to the top. All right, so that's how deep it is with open sunlight. All right, with still open sunlight. All right, so that is the Bingham Canyon mine in Utah. All right. So, in terms of drilling processes done by humanity, all right. So we haven't scratched yet the surface, but there are some scientific studies, or there are some scientific endeavors that is on their way to drill down the crust. All right, to drill down the crust and probably reach the mantle. Now, if they reach the mantle, they will be able to study the behavior of the mantle and somehow try to understand how earthquake happens. All right? So, as of now, we barely scratch the surface of the earth in those drilling process that we did on the first picture. All right? So, I will leave you a question here before we continue. So, the question is, if you will going to drill down to the earth, all right, in what part of the earth you were going to start drilling? All right. So the question is, in what part of the earth you will going to start drilling? All right, and you can still you can reach the mantle in no time. Okay, so that's the question. You can put it down in the comment section, right below this video. Yeah. All right. So before we go to the lithosphere itself, let's take a look at the history of where does the Earth's interior came from. All right. So around 4.6 billion years ago, all right, there is a star at the middle of our solar system, and that star is the sun. All right, and the sun itself produces or has this gravitational pull high enough to pull down those gas and dust particles around it. Right? So once the sun did that, it forms the planets. Right? It forms the planets around it. Okay, so probably there are a lot of planets during that time. All right, big and small, and okay. And eventually, this gas and dust condense, and they become the planets, right? That we know right now. Okay. So since there are a lot of planets during that formation, so there are a lot of planets that bombarded each other or colliding each other, and eventually they form a satellite. So something like that. So the Earth itself is not exempted on that. All right, there are some planet-sized objects that bombarded the Earth in the past, and as it does, it scattered fragments around it, and it became the moon that we know. All right, so there are some studies that the moon that we have right now, all right, the moon up there contains materials that is similar to the Earth's material. Okay, found here. All right. So, hey, now as the planets collide with each other, all right, it forms new planets, it forms satellites, and they're not only planet-sized object but also asteroids, comet bombarded these planets for several billion years ago. All right. So, as it does, it liquefied the Earth's surface and became a molten lava eventually. So, it looks like this one. Alright, so as you can see, the Earth is uninhabitable during that time. And, okay, now as time passes by, this particular molten lava cools down and eventually form the land that we know right now. All right. So as the bombardment and collision stops, all right, it cools down, and all right, and the hot place now, the on this planet is located at the center of it, which is the core. All right, and the core itself is made up of radioactive materials like uranium, thorium, and as we know, these radioactive materials tend to do radioactive decay. Now, when they does, all right, when they do nuclear decay, it releases a lot of heat when they do that, and it enables the core to be continually heated all throughout the millennia. All right, so that's how these particular materials help heating up our core. All right, so only the crust, all right, that is cool and hard, and the molten part of our earth is only found in the core. All right. So to give you an idea, what are the value of this? What are the extreme, or what makes the core an extreme place? All right. The pressure inside the core is 3.5 million atmosphere. Now in the surface of the Earth, it is only 1 atmosphere. All right, that's the standard pressure here in the surface of the earth. But if you go down there on the core, you will experience a pressure of 3.5 million atmosphere. All right, so that is 1,000 times higher than the surface. All right, now in terms of temperature, the average temperature here on the surface, all right, it's around something like 30 degrees. All right, so 30 degrees Celsius. But when you go to the core, all right, that is around 6,000 degrees Celsius. So it is hot. All right, now having a no having a molten core has an advantage, because this molten core generates enough magnetic field for the earth to be protected to harmful rays or harmful materials that comes from the sun. All right, harmful cosmic rays or harmful sun rays that comes from the sun. All right, so it creates magnetic field, and it protects the earth by forming an atmosphere on it. All right, so without this molten core that we have right here, earth will look like a planet just like Mars. Right, now since we are done with the interior, so why not take a look at the layers of the earth? All right, so we have the 3 layers of the earth right here. We have core, mantle, crust, or crust, mantle, core. Yan, if you will arrange them respectively. So okay, these are the 3 definite layers of the earth. But if you will consider their characteristic, their individual characteristic, you may end up having the core divided into 2. We have the solid metal core, that is the first layer that you have right there. Then the second is this outer molten metal, all right, the outer core. Yeah. All right, and above it we have the mantle, which is the third, and the fourth one is the crust. All right, if you further divide also the mantle, there are 2 layers of your mantle. So we have lower and upper mantle. So lower mantle is different from the upper mantle in terms of their density and composition. All right, and also the crust itself is also divided into 2 types or 2 kinds. All right, so we have continental crust and the oceanic crust, which is also divides the crust into its different density and then composition. So overall, we have 6, all right, 6 layers of the earth. All right, if you include those layers that I've mentioned a while ago. But for simplicity purposes, there are only 3. We have the core, we have the mantle, and then we have the crust. All right. So, what is the composition of the Earth? So, typical composition of the Earth is one of the dominant element here is iron. All right. So, which is found on the core itself, and the nickel. Okay. Oxygen being the second. Third is magnesium. Fourth is silicon. Fifth is sulfur. Then so on and then so forth. All right. Now, if you will going to categorize them according to its layer, so the dominant element on the crust is oxygen, mostly oxygen, and followed by silicon, then aluminum. All right. So there are some small traces, or there are some iron, all right, but in somehow in a small amount. All right, so we have the mantle, all right, which is made up of olivine and pyroxene. So these are minerals that are found in the mantle, and these are subjected to high pressure and high temperature. All right, next one is the core, which makes up the all right, the core is made up of iron and nickel respectively. All right, so what does okay, what an olivine looks like? It looks like this green material that is on the picture, and the pyroxene is something like this one. Okay, that you have right here. All right. So these are the materials that are likely to be found on the mantle, all right, which is the largest, right? So the largest layer, okay, of the earth, yeah, the mantle. Alright, so how do we know what Earth is made of? So basically, we have people called geologists. So geologists, volcanologists, geodetic engineers, alright? So these people, okay, these people be able to know what Earth is made of because of land, air, and sea survey. All right. Now, in modern times, we have now the satellite as a highly technological advancement in order to survey the Earth from outer space. All right. So, also, there are surveys in mines, digging a deep boreholes. All right. Some field works, like the one that we have right here. All right. It's necessary for us to study how the planet behaves. Okay, so without the geologists, without people like geologists, we don't have any idea what our planet is made of. All right. Okay, let's go to the first layer, which is the layer that we will going to discuss on this session. That is the crust. All right, the crust is where we live. All right, this is where we live, and the Earth's crust is made up of two things. So we have continental crust and then the oceanic crust. All right. Now, in terms of dimension, continental crust is thicker than the oceanic crust, which is thinner by around 7 kilometers thin. All right, and the continental crust is around 10 to 70 kilometers. All right, so that's their dimension. All right, in terms of density, we have here the continental crust is less dense, so meaning to say that it will float above the mantle. All right, because mantle is more dense than the crust. So if continental crust is less dense, so it will float above the mantle. Whereas oceanic crust, although all crusts are less dense, but in terms of these two, in terms of the difference between these two, oceanic crust is denser than the continental crust. All right, so it will likely to sink. All right, it will likely to sink deeper down the mantle than the continental crust. All right, so in terms of age, the continental crust is mostly old and the oceanic crust is young. All right, in terms of age. Now, I will leave this question to you. Why is it that the oceanic crust is younger than continental crust? All right. So, I will give you a clue. The answer for that question relies on the topic or on the concept of plate boundaries. All right. So, that will answer that question. Why is it that the oceanic crust is younger than its counterpart, which is the continental crust? All right. So what is the crust anyway? All right. So the crust is the solid, brittle material that surrounds the Earth. All right. If you happen to see a picture of Earth from different medias, the one that you see there outside is the crust. Okay. Even though it is covered with water, the one underneath that water is the crust itself. Alright, so it is a brittle material and okay, the differences between some crust, as I mentioned earlier, depends on what surface you are living in. Alright, if you are on the continental crust, obviously it is different from its counterpart, which is the oceanic crust. Now, in terms of dimension, I mentioned a while ago that the oceanic crust is thinner than the continental crust. Now, in terms of density, oceanic crust is denser than the continental crust. Now, this is a topic for another day, but I will just include it right here. Seismic wave move faster, alright, on the oceanic crust than the continental crust. So, I will leave a question to you. You can write the answer in the comment section below. So, what makes the seismic wave travel faster to the oceanic crust? What factors in the oceanic crust allow seismic wave to travel faster than in the continental crust? All right. So I want to hear your I want to hear or want to see your answer on that question. Just write it down in the comment section below. All right. So in terms of material, not all crusts are also made. Not all crusts are made equally. All right. In terms of material, continental crust is made up of granite. All right. So this rocks that you have right here is can likely be found on the continental crust, whereas the basalt is found on the oceanic crust. Alright, these are found in the oceanic crust. So, it contains silicon and magnesium, and the granite contains silicon and aluminum. But in terms of the number of these materials that or number of elements that you have right there, silicon is more dominant in granite than in basalt. So, basalt has more iron than silicon. Alright, so that's the reason why, okay, because of these elemental differences, alright, because of this composition, it allows the oceanic crust to become denser, whereas the granite will become less dense. Alright, so that's their composition. Okay. Alright, the next part, okay, the next layer after the crust is the mantle. Alright, so but before, the mantle is not included in this lesson, but I will just have a short description on it. Alright, so before we go to the mantle, alright, so the mantle and the crust is separated by by one boundary, which is called the Mohorovičić discontinuity. Alright, so in honor of this man, yeah, the one on the picture, and alright, this boundary is found between crust and mantle. Alright, so crust and mantle. So Mohorovičić discontinuity, or MOHO for short. Now, what happens there if a seismic wave passes through that area? It allows the seismic wave to travel faster. Okay, it allows the seismic wave to travel faster, and that is because the materials are on that particular part is denser than the one on the crust. So probably it allows the seismic wave to travel in high velocity. Okay, next one. All right. So because continental crust is less dense and it has the granite type of rock, right? And that makes it float above the mantle. Whereas the oceanic crust is more dense, that allows it to sink on the mantle. All right. So these differences, all right, these differences in density allows these two types of crust to behave differently. All right. So let's take a look at the simulation. Generously provided by PHET simulation. All right, in order for us to study what is on this content that we have right here, let's take a look. All right, so here we are on our simulation. Now on this simulation, we will try to change the composition and the thickness of the crust that you have right there on the background, and I will just have a short description or short discussion regarding the temperature. All right, so let's take a look. Okay, in this particular simulation, all right, so you can adjust the composition, all right, having more iron or having more silica on the crust. All right, also the thickness. All right, let's take a look. All right, if we adjust this one to a more iron, so what happens? All right, so the crust, okay, the crust sinks, all right, on the mantle. All right, so if we happen to show the labels here, this is the crust and this is the mantle. All right, now, if you adjust the composition to the side of more silicon, what happens is it floats above the mantle. All right, so that crust floats above the mantle. So therefore, it is a continental crust. So going back again, if you change this one to more iron, it becomes an oceanic crust and it is more denser than the continental crust. So now what if we put thickness on the picture? Alright, so if we adjust the thickness on this simulation. Now if you have more iron and then you are thin, alright, so you will sink more. Okay, you will sink deeper to the mantle compared to the crust. Right? You will sink deeper to the mantle. That's the reason why all ocean basins on this planet are deep. Alright? If you will have a question why oceans are deep, why ocean basins are deep, it's because of its dimension and composition. Alright? So now if we adjust the slider down to the more silica and make the thickness more thick, so it will float, alright? It will float high above the mantle, alright? So the crust, alright, with higher thickness and more silica will float higher above the crust. Alright, and that's the reason why, alright, this particular simulation will give you the answer why Mount Everest is so tall. Right? So it will give you an answer to that question why Mount Everest is so tall. Okay, so it's because of this configuration that we have right here. All right. So now let's take a look at the temperature. Okay, let's put it right here. Okay, at default level. Okay, now in terms of temperature, alright, so let's take a look first at the density. Maybe you have doubts on what I'm talking about. Alright, so in terms of density, the one with more iron, right, so the one that has more iron is more dense than the one that contains more silica. Alright, so as you can see, alright, their density differs. Yeah, so it differs. Alright. Now in terms of temperature, so as you can see here, alright, so the temperature of oceanic crust, so let's see. Okay, so there's no difference in terms of temperature between continental and oceanic crust. Now if you will compare them to the next layer, which is the mantle, so it is completely different. So the temperature, both crust, alright, so both crust share the same temperature, being colder than the mantle. Alright, so okay, so don't forget to visit the PHET simulation site. So that you will be able to discover more about this particular concept about the oceanic and continental crust. So one good thing about this simulation, it has also the plate motion. Okay, so when you do, don't forget to donate on their website. All right, so to continue to provide us more of this simulation in the future. All right, so let's go back to our slide. Okay, so there you have it. So that is the simulation. So the simulation tells us the differences between oceanic and continental crust. Okay, there you have it. Okay, now since we discussed or since we added up the mantle in our discussion, okay, so maybe we can include the special layers between crust and mantle. All right. On this lesson. So this is where the lithosphere falls. Alright? So what is a lithosphere? Some people are being confused by lithosphere being confused as synonymous to crust. Alright? Okay. It might be, but lithosphere is different from crust because this is a special layer. The crust is the main, the outermost layer. The lithosphere is composed of two things aside from the crust. Yes, it is made up of crust, but aside from crust, it has another one. All right. So the lithosphere share the characteristics of the crust, which is being solid and brittle, and it sits above the asthenosphere. All right, which is the next layer after this. All right. And as I've said earlier, lithosphere and crust are not synonymous. All right, in which the crust makes up the lithosphere. All right. Now, what are the things included in the lithosphere? We have the crust. All right. So we have the crust over there. We have the moho, and the upper part of the mantle. So this is what makes the lithosphere different from the crust. The crust is the crust. It is what it is. But the lithosphere contains this and that, the upper mantle. All right? So that's the lithosphere. That's the outer part. All right. Next is the asthenosphere, where the lithosphere is seated on. Alright. Now, the asthenosphere doesn't have any crust in this composition. Alright. It doesn't have crust in its composition, but it is made up of upper mantle. Mostly upper mantle. And it is found on the range of 100 to 200 kilometer deep, right? It is found there. What happens to the seismic wave as it passes here? It somehow it slows down. All right, it slows down the seismic wave as it travels here because the asthenosphere is a layer that is hot and semi-fluid. All right, so this is a weak. All right, this is a weak plastic layer of the Earth, the asthenosphere. Okay, so if a solid brittle rock is seated above the asthenosphere, all right, is seated above the asthenosphere, what will happen? It will likely to break down. All right, so but before I show you that, all right, so this is what it's look like. So continental crust are part of the crust. There you go, oceanic crust as well. All right, and the one at the bottom of the crust is the mantle. So the one that you have right here. What part of the mantle? To be exact or to be specific, that is the upper mantle. All right, so the lithosphere is extended from the crust down to the parts or some parts of the upper mantle, the one that you have on this picture, right? Then the one at the bottom of the lithosphere, which is made up of mostly mantle, that is the asthenosphere. All right, this is a semi-fluid. All right, if you are familiar with contact cement, all right, if you are familiar with contact cement or a slimy, something like that, that's the characteristics of the asthenosphere. Alright, so since it has that composition, the tendency is the lithosphere will likely to move above it. Alright, so but before we go to that, the moho is located there. Alright, so the moho, that is the moho. Alright, next one, the boundary between lithosphere and asthenosphere is called lab. L-A-B. Alright, so lab, which means lithosphere, asthenosphere boundary. Alright, so that's the boundary between them. Alright, so the lithosphere seems to be detached. Alright, the lithosphere seems to be detached from the asthenosphere. So that's the reason why when it moves, it breaks down. Alright, it breaks down, or when the lithosphere moves, it breaks itself into several plates, just like an ice floating above water. Alright, so that's the reason why the Earth is made up of several plates. Okay, so if you happen to see an iceberg or some ice sheets, all right, ice sheets on top of the water, as you can see, these ice sheets, when they move, they starting to break apart. All right, when they start to break apart, they separate. All right. So just like the one that we have right here, the icebergs, all right, so the ice sheets, lithosphere behaves like that. Okay, so because of that behavior, the lithosphere here on Earth is broken up into several plates. We called it tectonic plates. All right, we called it tectonic plates. But when you rearrange that word to become plate tectonics, the one that you see on this slide, when we talk about plate tectonics, that is a process. All right. Okay. So when we talk about tectonic plates, that is the lithospheric plate. All right. That is the lithospheric plate. All right. The tectonic plates or the plate tectonics is the process. All right. The process of destroying lithosphere via earthquake, volcanoes, and mountain building. All right. So when the lithosphere moves, depending on what process you have here, all right. So when the lithosphere moves, it will likely to be destroyed in the process. All right. So that is the plate tectonics. That is a process. All right. The plate itself, The plate itself is called the tectonic plate. So you just rearrange the word. Alright. So, alright, since we are talking about the plate tectonics, which is our next topic in the future. Alright, so there are, okay, this is a picture of how the Earth's lithospheric plate or tectonic plate is being divided into two things. We have major plates and then we have the intermediate plate. Alright, let's start first with the major plate. When we talk about major plate, these are plates that is considered to be large. Alright, these are big plates. Alright, so I hope you can see on the picture these major plates that I am talking about. Now, the intermediate plate are plates that are in between the major plates. Alright, not necessarily that they are very small, but these plates are in between the major plates. Alright, so let's start first enumerating what are those. Alright, so let's start first with the major plates. So these are the major plates. So we have one. So the Australian plate, the Pacific plate, the Eurasian plate, then we have the North American plate over here, right? So then we have the South American plate, the Antarctic plate at the bottom, then the African plate over there, then we have the Indian plate, and we have the, okay, the Eurasian plate is just the continuation here. All right, so all in all, we have 8. All right, we have 8 major plates. All right, so as you can see, they are large. Among them, the largest of them is the Pacific plate. All right, in terms of land area of around 100,000 something. All right, so 100,000 kilometers. Okay, square kilometers, something like that. All right, so 1 million, I think. 1 million or in that range. All right, so the Pacific plate, in terms of land area, is larger than all of the major plates that you have right there. All right, let's take a look at the intermediate plate. So as you can see, the Philippine plate that you have right here, all right, so the Philippine plate that you have right here, all right, is in between the Eurasian and the Pacific plate. Alright, so that is why it is called intermediate plate or in-between plate. Alright, so we have the Juan de Fuca plate. Then we have the Cocos plate over here. We have the Nazca over there. We have the Scotia plate. So, 2, 3, 4, 5. Then we have the Caribbean plate, 6. Then we have the Arabian plate, that is 7. Alright, so there are 7 intermediate plates. So as you can see, yan, it is in between those major plates that is on this picture. Alright, so technically speaking, these are all part, or these are the plates that you see on the picture are all lithosphere. These are lithospheric plates, all right, which are broken down into several divisions that you have right here because these plates has its own plate boundaries. The one that we have right here, these are plate boundaries, and that will be a topic for another day. Right, that will be a topic for another day. What are these plate boundaries, and what is the effect of these plate boundaries in the overall characteristic of a lithospheric plate that you have on this picture? All right, so that is the tectonic plates. All right, these are the tectonic plates. Right, so before we end up this video lesson today, we learned that the Earth is made up of several layers. All right, to be exact, so we have, all right, so the Earth is made up of several layers. So we have one that is crust, then followed by mantle, then followed by the core. All right. And also, today, you've learned that the crust is made up of two of its kind. All right. So we have the continental crust, right? So continental crust and the oceanic crust, which differs in terms of magnitude, or rather dimension. Okay, dimension, thickness, and the thickness. Yeah? All right. So next one is the density. All right. Next one is the age. Right. So that is the crust. Continental is less dense than the oceanic crust. Continental is thicker than the oceanic crust, and oceanic crust is younger than the continental crust. Alright, next, you've learned also that the lithosphere is made up of the following layers. So we have crust, alright, we have the upper part of the mantle. Okay, so don't forget also the moho. Right? So that is the lithosphere. This is the solid brittle layer that sits above the asthenosphere. All right, so the asthenosphere is the layer that that is part of the upper mantle. It is a weak plastic layer in which your lithosphere sits above. All right, so because of this arrangement, it gives way to the idea of what they call the plate tectonics. All right, in which this is the process of destroying the lithosphere. All right, so plate tectonics is the process of destroying the lithosphere via earthquake, volcanic eruption, okay, volcanic eruption, all right, so, and also mountain building. All right, so these are the processes in which you can destroy a lithosphere. Now, there is, if you switch these two words together, if you switch places, you can have your tectonic plates. And tectonic plates means this is a big slab of rock. All right, this is a big slab of rock that divides, all right, the lithosphere. Right? So that is the tectonic plate. Okay, so if you learned all these things today in this video lesson that I have right here about module number 1, all right, so it will be a great success. All right, great success. Okay, so with that, all right, so with that, okay, that ends up our video lesson today. So I hope you did learn something new from this lesson that we have right here. All right, so if you have a comment, you can put it down in the comments section below this video. So if you want to be updated with more videos like this in the future, just hit the subscribe button and the bell button beside it. And don't forget to like this video. It will help me a lot. Alright, so that ends up our video lesson. Let's see each other again to the next science video lesson. Bye guys!